Hello friends, welcome to engineering tutorial. Now in the next series of videos we are going to start a new discussion about a new section which is network theory. I've already posted some videos related to network theory in the past, which was a long time ago. So we are again going to touch that section. So we are going to discuss a lot of things related to the basic concepts associated with network theory or circuit theory. So we are going to start with the very basics, the ABC of network theory, so that we understand each and every concept associated with this subject in detail. So we'll discuss a lot of things starting from the basics. So in today's video, which is obviously related to network theory, we are going to discuss about the basic concepts of resistive circuits, which means circuits involving resistors only. So whenever the term resistance comes into discussion, we have to discuss Ohm's law. Okay, we all know Ohm's law starting from high school, but because we are going to go into this discussion systematically, so let us just discuss it again. Basic Ohm's law. So what the Ohm's law states that the current flowing through a resistor in a circuit is directly proportional to the applied voltage and inversely proportional to the resistance. Okay, so I is equal to V by R, where V is the applied voltage and R is the resistance. The unit is ohms. We know current is in amperes and the voltage is in volts, or we can write V is equal to IR. So this is basic Ohm's law. So here in this circuit, where V is the applied voltage, it is a DC voltage, we have the resistor R and we have the current flowing in this direction. So we get the current flowing in this circuit is directly proportional to this applied voltage and it is inversely proportional to the resistance. So what it means is that with an increase in voltage, there will be an increase in current flowing through the circuit, because current is directly proportional to voltage and the current is inversely proportional to this resistance value R. It means an increase in resistance will cause a decrease in the current. Okay, an increase in resistance will cause a decrease in the current. Okay, so this is what this two relationship just implies. Okay, so there are different ways in which we can write. We can either write I is equal to V by R to calculate the current flowing in the circuit, or we can write V is equal to IR to calculate the voltage drop across the resistor R. Now, from this term, the voltage drop across the resistor R, there will be a lot of things which can be confusing, okay, related to the sign convention of this voltage drop. So let us just discuss that in detail. So now we'll discuss some concepts related to voltage drop across resistors. Okay, so as you can see, there are two figures that are drawn, okay, which involves a resistor and current flowing through the resistor. Now focus on figure number 1. Okay, the current is flowing from left to right through the resistor. Now pay attention to the plus and minus sign at the top in green color. Okay, it is flowing from positive to negative terminal internally through the resistor. Okay, it is flowing from positive to negative terminal internally through the resistor. So whenever current flows through a resistor, it will always flow from positive to negative terminal internally. It means, or what it represents is that this resistor is absorbing power from an external voltage source. So whenever current flows through a resistor, this will be the sign convention, the polarity which will be placed on the resistor, plus and minus. It will enter through the positive terminal and exit from the negative terminal through the resistor, because resistors always absorb power. Okay, this means that the resistor is absorbing power. If it would have flown from negative to positive internally, it means it is delivering power. Okay, if here it would have been negative sign and here it would have been positive sign, it means this resistor would have been delivering power, it would have been supplying power, but that is impossible. Resistors can never supply power, they can only absorb power from an external voltage source. Voltage source, they supply power. Okay, so here the thing to remember here or to take note of is that whenever current flows through a resistor, this will be the polarity which will be placed on the resistance. Now VR is the voltage drop across this resistor which is being measured. Okay, VR. Now you can see that the voltage drop is being measured in the same direction as that of this polarity, plus minus. Here also the voltage drop is measured in the same direction as that of the voltage, means the voltage drop across the resistor, the sign convention. Here it is also plus, here it is also plus, here it is minus, here it is minus. So in this case, when the voltage drop is measured in the same direction as that of the polarity which is placed on the resistor because of the current flow, the voltage drop will be given by this expression. VR is equal to IR, or VR is equal to plus IR. Okay, the voltage drop will be plus IR because it is being measured in the same direction as that of the sign convention which is placed on the resistor depending on the direction of current flow. The current will flow always from positive to negative terminal of the resistor internally. It will enter through the positive and exit from the negative. The voltage drop VR is measured in the same direction, plus plus minus minus, so VR is equal to IR. In this circuit, everything is the same. Current is flowing in this direction, it means there will be plus sign here, minus sign here. It will flow through the positive terminal, exit from the negative terminal. But here the difference is that the voltage drop is measured in the opposite direction as the sign which is placed here. Here it is plus, but here it is minus. Here it is minus, here it is plus. This voltage drop across the resistor, here we are also measuring the voltage drop, but we are measuring it from this side, from positive to negative, in the opposite direction. Here we are measuring from this side, from positive to negative this side, which is the same as that of the polarity which is placed on the resistor. But here it is in the opposite direction. Here it is plus, but here it is minus. Here it is minus, here it is plus. So in this case, this voltage drop will be given by this expression. VR is equal to minus IR. Here it is plus IR, here it is minus IR. The only difference between these two figures is that here the voltage drop is measured in the same direction as that of the sign which is placed, the positive and negative sign which is placed on the resistor. Here we are measuring in the opposite direction. These two things are constant. Okay, whenever current will flow in a particular direction, it will always flow from positive to negative terminal to a resistor. Here also this thing will remain same. It will always flow from positive to negative terminal. We cannot change this. This can never be changed because resistors will always absorb power. This top thing can never be changed. But we can measure voltage drop in whichever direction we want. We can either measure it from this side to this side, or we can measure it from this side to this side. It depends on us. So in this case the voltage drop will be plus IR, in this case it will be minus IR. Okay. Here we will discuss another important thing related to measurement of voltages across two terminals. Okay, it is similar to the concept which we discussed just earlier related to measuring the voltage drops across a resistor. It is the same thing, but it is just expressed in a different way, but the concept remains the same. Okay, so let's discuss it. So in this circuit, as you can see, the same, we have a voltage source V, a DC voltage source and a resistor, and a current flows through the circuit. So the current flows from positive to negative of the resistor, this is the same. Now let us say that across the terminal A and B, the voltage is measured from A to B, okay, plus and minus, measured from higher to lower potential. Okay, if it is measured in this way, okay, with positive at A and negative at B, let's say that the voltage is VAB. Okay, let us say that the voltage is VAB. Here the circuit stays the same voltage source in the same direction, same resistor, and the same current flow in the same direction from positive to negative through the resistor. But here the difference is that the voltage is measured from B to A. Okay, B is positive, A is negative. So it means that the voltage is measured from bottom to top. Here it was measured from top to bottom, from A to B. Here it is measured from B to A. B has is positive sign and A has negative sign. So in this case, this voltage which is measured, it will be minus VAB. It will get a minus sign. So it all depends on in which direction we are measuring the voltage. The magnitude of the voltage will stay the same. It will always be VAB. Here it is also the magnitude is VAB. If it give a modulus sign, the magnitude will stay the same. It will be VAB, it will be VAB. But in this case, it will be negative VAB, minus VAB, because it is measured in the opposite direction as to this circuit. Okay, here it is measured from positive to negative, from top to bottom. Let us say that this is VAB, we get this value as VAB volts. Here we are measuring it in the opposite direction, from bottom to top. Here it was top to bottom. Measurement was done, the voltage was being measured from top to bottom. The voltage between terminals from A to B. Here it is measured from B to A. So it is minus VAB. For example, let us say in the same circuit we got the voltage between terminals A and B from A to B. A has positive, B has negative. Let the voltage between terminals A and B from A to B, the voltage from A to B is 9 volt. Let's say it is 9 volt. If we measure it from B to A, the voltage between terminal B to A, it means that it will be minus 9 volt. The voltage between terminals B and A measured from B to A, means B has positive and A is negative. Voltage is always measured from a positive sign to negative sign, a higher potential to a lower potential. So in this case it came as 9 volt, in this case it is minus 9 volt. The magnitude is the same, 9, but only the sign changes. So this is the same thing which we discussed in the previous concept related to voltage drop across this resistor. Current always will flow from positive to negative. Okay, this will never change because resistors always absorb power. But the manner or the direction in which we measure the voltage drop, that we can control. That is our wish. So depending on that, the voltage drop will get either positive sign or negative sign, depending on in which direction we are measuring. Okay, so this is the concept related to voltage, measurement of voltage across a circuit or across a network. So now here it is another, we'll discuss another concept related to current flow in the circuit and the sign convention associated with them. So here also we'll discuss two circuit networks, we'll compare two circuit networks. So here in this circuit network, we have a voltage source, a DC voltage source V, and a resistor R. We're discussing resistive circuits. So let's say a current I1 flows through the circuit through resistor R in this direction from left to right. Okay, from left to right, I1. And let's say the value of I1 is x ampere. I1 is equal to x ampere. Now, the same circuit, we have redrawn the same circuit, but now we want to take the direction of this current in the opposite direction. Okay, we want to take it in the opposite direction. Here we will take it from right to left in this direction. Okay, so here this current I2 will be minus x ampere. Here it was plus x ampere, here it is minus x ampere. Here pay attention that the magnitude of the current stays the same because all the values in the circuit networks are the same. V is V, R is R, the resistors value are not changing, the voltage values are not changing, the polarity of the voltage is not changing. Only we have taken the direction of the current in the opposite direction. We are saying that we will take the current direction in this direction. Now, here the value of the current will get a negative sign. Similarly, we can measure the voltage in whichever direction we want. Okay, we can measure it from positive to negative or from negative to positive in whichever direction we want. Similarly, we can take the current direction arbitrarily as per our choice. But we cannot say that I2 is equal to x ampere. We cannot write it like that. That will be wrong. The polarity, the negative sign or positive sign which appears on the current, we cannot change that. We can change the direction of the current, we can take as in whichever direction we can want, but we cannot change the value of the current. If we take the direction of the current in this way and we get a value as x ampere, we get a value as x ampere, then if we reverse the direction of the current, the magnitude will stay the same, but we will get a negative sign, minus x ampere. Let's say if the value of current in this circuit in this direction is 9 ampere, then if we reverse the direction of the current, the magnitude will stay the same, but we will get a negative sign. It will be minus 9 ampere. Here it is plus 9 ampere. Let's say we have just considered that the current flowing through the circuit is 9 ampere. If we reverse the direction of this current, then the magnitude will stay the same, 9, but we'll get a negative sign. Okay, so you can also see it in this way. Let's say the current flowing through this direction is I2 is minus 9 ampere. Then the opposite, in the opposite direction I1 will be minus of minus 9 ampere, which will be plus 9 ampere. You can also see it in that way. Either way it will be correct. But minus sign will appear when we change the direction of the current. Okay, the direction in which we are measuring the current. Here it was flowing from this direction, we have taken this direction, but here we have considered this direction. So the magnitude will stay the same, but we will get a minus sign. So the relationship between the current flows in this circuit I1 and I2 is that I1 is equal to minus I2 because of a simple change in the direction of the flow of current. Okay, so here we have discussed some concepts related to resistive circuits such as Ohm's law, then the voltage drop, measurement of voltage drop across resistors, the way in which we measure voltage between two terminals, and also concepts related to measuring the current flow in a circuit. So in my upcoming videos we will discuss some more basic concepts related to network theory such as KCL, KVL, then mesh analysis, nodal analysis, and other related things. So please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.